Hello, my name is Lindsay Broadway, and this is Lab 2, Motion of a Falling Object for Physics 2211 at Georgia Tech. So to start off, the purpose of this lab is to show how the forces of drag and gravity affect the velocity of an object falling from rest. In the diagram to the right, I used an eraser and then the downward arrow to show the force of gravity, which is mass times the gravity constant on Earth, and then the upward arrow shows the air resistance or the force of drag. The models and principles that are key to this lab, one of them is Newton's second law, which is shown in the figure to the bottom right. Basically, when a force acts upon an object, the object accelerates in the direction of the net force. So basically, the net force in this case is pointing downward because gravity is greater than drag, so the eraser accelerates downward. The system is the eraser, the surroundings are earth and air resistance, and the initial conditions are the eraser starts at a little above 1 meter, and then it has an initial velocity of 0 meters per second. Some useful formulas that can be derived from Newton's second law are the velocity update formula, which is final velocity equals initial velocity plus net force divided by mass times change in time, and the position update formula, which is final position, which is equal to initial position plus average velocity times the change in time. And then finally, to find the force of drag, you multiply the drag constant of the object times the instantaneous of the velocity, or the instantaneous velocity squared. So here's my experiment. You can see I drop the eraser and then tracker tracks the object as it falls. A closer up on the data that I used, that the upper part is the graph of the y by the time in seconds, and then the bottom chart just shows the specific points used in that graph. So then after doing the experiment, I created a computational model which showed the impacts of just gravity on the eraser. I inputted the mass of the ball and the initial position of the ball, and then I used the mass times the gravity constant of Earth to find the net force acting on the ball because this model is just showing gravity. And then I used the velocity and position update formulas to kind of update the position of the ball of the eraser as it falls. And this is what the position versus time graph shows using the model. The next model that I made was for gravity and drag. So the key difference here is that at the bottom down here, I kind of went through trial and error to find a drag constant that worked for the eraser, and that matched my experimental results. And then I did the same thing. I used the gravity force and then added that to the drag force to get the net force, and then I used the same velocity and position update formulas. And this is what the drag and gravity model showed. So it did not fall quite as fast as the gravity model because there's an upward force acting on the eraser. So in this graph, I plotted the experimental data, the just gravity computational model, and then the gravity and drag model. And you can see that the gravity model fell the fastest because there was no drag in play. And then the experimental model was next, and then the gravity and drag. And I think that some sources of error could be that my drag coefficient was off. It was just a rough estimate. And also my experimental model was a little off because I started the eraser too high above 1 meter. So finally, one of the questions was which model predicts terminal velocity, which is when the object falling comes to a constant velocity because the force of drag is equal to the force of gravity. And in this case, the net force on the eraser falling did point downward, so the eraser accelerated constantly downward. But in the gravity and drag model, you can see that the curve started to flatten out, making it kind of like a linear curve. So it was heading toward its terminal velocity. The second question is, if the object was like thrown downward first, would this affect the terminal velocity? And I said no, because initial velocity is irrelevant to terminal velocity. Terminal velocity is dependent on weight, not initial velocity. Thank you.